Hello, Math 2 students. Okay, so this is your classwork, 2.1.3, Factoring Trinomials. It's Wednesday, and the top part of this is blank because this actually included some of the work from yesterday's classwork, so I just put a white rectangle over it. So Factoring Trinomials is our first section, and all of these trinomials, all these quadratics, remember we might also call them quadratics, all of them have a coefficient of what we call a coefficient of 1. So again, these are called quadratics. A lot of times you will hear this word a lot in Math 2 and Math 3. So all of these, before the x squared term, there's nothing there. So that means it's a 1 on all of these. So that makes this a lot easier to factor. We don't have any that have any other numbers today. We're gonna dive into that a little bit more in detail later, but for right now I just really want you to get used to doing what we call a equals 1 quadratics. So if you remember from your notes, what we want to do is we want to look at this term right here, and we want to list the factor pairs for that number. You know, sometimes you can just think of them in your head, and that's fine. But what we want to do is we want to think about the factor pairs for this number, and we want to find something that when we multiply it, we get the 6, and when we add it, we get -7. So we're looking for factor pairs for 6 that add up to -7. All right, so factor pairs for 6 would be 1 times 6, 2 times 3. Now remember, that's not all. You also have -1 times -6 and -2 times -3. So make sure that you think about all the possibilities. Okay, so when I put a plus between these, plus there, all the way down. So which one adds up to -7? Well, it would have to be this one, the -1 and the -6. So those are the numbers that are going to go in my parentheses for the answer to this. So I'm going to have an x here and an x here, and then I'm going to have this -1 and the -6 in parentheses. So that's the answer. We just factored that trinomial. Okay, now on the next one, we've got a little bit bigger number. We've got an 84, or actually a -84. And what we can do, and I want to show you on the graphing calculator. I'm going to pull up my graphing calculator here. I do want you to think about the fact that one of the numbers is going to be positive and one is going to be negative. So when we add them together, what we're really doing is subtracting, but I'll get to that in a second. So on your graphing calculator, if you have one, if you don't have one, you can go download the free version by going to my online resources on my Canvas page. All right, so what you'll do is you'll click the Y equals button, which I've already done, which brings up this. Okay, and then after the equals, you'll put your number. So my number was -84. So put the number in, and then put divided by x, and x is right here. Okay, and then you want to hit second graph because you actually want to create a table. Okay, and so what you see here is we have a table with some of these numbers would work. The 4 times -21 might work, the 6 times -14, but right here we have a -16.8. So we only want to look for whole numbers. All right, so I'm going to slide this over. Let me make this so I can actually look at my calculator and do this at the same time. So some of my possibilities are 4 times -21, 6 times -14. What else do I have? 7 times -12. Well, right there, that looks terrible. 7 times -12. 7 times -12. If I put a plus sign in there, that would equal -5. So 7 plus, and that looks like a 72, sorry. 7 plus -12 equals -5. So I have found my pair of numbers that needs to go in my parentheses. X plus 7, X minus 12, because this was a -12 right here. So this is factored. So if you have bigger numbers like this 84 or 378, 457 or whatever, you can use your calculator to find your factor pair so you don't really have to think, okay, what in the world do I multiply to get -84? You can go over here and use your calculator. And I'll do it again too if we have a big number again. 30 is not too bad, but if we have a bigger number, we'll go over there and do use the calculator again. Okay, let's look at our next one. I need factor pairs for +30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. Okay, so 5 and 6, when I add them together, I get 11, but they both need to be negative. And negative 5 times negative 6 is 30. Negative 5 plus negative 6 is negative 11. So this is my pair that I'm going to use right here. So I have two binomials. I have an x in each one. I have a negative 5 or a minus 5 and a minus 6. So that's all there is to that. All right, let's go over here. Okay, so I have a positive 20 and a positive 12. So let's list factor pairs for positive 20. 1 times 20, 2 times 10. What else do I have? Oh, that one works, doesn't it? 2 times 10. So 2 times 10 is 20. 2 plus 10 is 12. So that works. X plus 2, x plus 10. And if you use box method and you multiply these back out, you would get this original quadratic here. All right, let's do this one. So I have a negative 48. Negative 48, I need factor pairs for negative 48. I'm going to go use my calculator. So, all right, let's see. Y equals, I can get rid of this. Oh, I keep thinking I can click over there and it'll enter something for me. All right, negative 48 divided by x, second graph. Okay, so here's my table. So I have 4 times negative 12. 4 times negative 12, that won't work. 6 times negative 8. Okay, that doesn't equal positive 2. 8 times negative 6. That does equal positive 2. When I add those two together, that equals positive 2. So it's positive 8, x plus 8, x minus 6. All right, last one. Okay, negative 54, I'm going to do on my calculator again. So let's go back to my y equals. We'll clear that. Negative 54 divided by x, and then second graph. Okay, so what have I got? I'm looking for whole numbers. 6 times negative 9. That won't work. 9 times negative 6. That will work because 9 plus negative 6 is positive 3. So x plus 9, x minus 6. All right, and that's it. You will have a quiz this Friday, and it will include those types of quadratics. Okay, difference of two squares. Difference means it has a minus between the two numbers. So the first thing we want to do is decide, is this a difference of two squares? And x squared plus 25, if it had a minus, it would be a yes. This is a no, so if we answer no, we don't have to go any further. Let's look at the next one. X squared minus 49. Okay, it is the difference because it has a minus. X squared is always, that's a square of x. And then 49 is 7 squared. So this would be yes. So then let's factor this. We have an x plus something and an x minus something, and it's going to be 7 because that is the square root of 49. All right, the next one, x squared minus 9. Is this a difference of two squares? The answer would be yes, because 9 is a square, is what we call a perfect square. X plus 3, x minus 3. Okay, I might leave a couple of these for you. Okay, 625. Well, if I don't know if that's a square, because I do have a difference, if I don't know if that is a perfect square, what I can do is go over to my calculator. And, okay, so I'm going to go over my calculator, and it's still in this y equals setting. So to get out of that, hit second, and then mode, which is quit. Okay, so I'm going to enter my 625, and then here's my square root button right here, and so I need to enter second and then x squared, which is the square. Sorry, I'm so used to doing this with the iPhone. Okay, so let's do second square root 625, enter. Okay, so the square root of 625 is 25. So it is a perfect square. So my answer would be yes, this is the difference of two squares. And factored would be x plus 25 times x minus 25. Okay. X squared minus 8. 8 is not a perfect square. It's actually a perfect cube, but this is not difference of two squares because 8 is not a perfect square. 1 is a perfect square. 1 squared is 1. So this is a difference of two squares. My factored version would be x plus 1, x minus 1. Let's look at the rest of them. We're going to answer yes or no together, and then I want you to factor them. Okay, x squared minus 36, yes, 36 is a perfect square. I want you to try to factor that one. X squared plus 1, no, that's not a difference. It's two squares, but it's not a difference. And then 24, I want you to see if you can determine whether 24 is a perfect square and whether you can factor that. So I want you to answer yes or no, and also factor it if you can. Multiply a monomial by two binomials. I did some of these on the notes, or I think I did one of them. Here's what I would do. I would multiply this part first, and then I would use box method. Okay, so I'm going to distribute this 4 in. That is 4x plus 4. Leave it in parentheses, x plus 1. And then I would use box method to finish this out. 4x plus 4, x plus 1. Okay, 4x times x is 4x squared. 4 times x is 4x. 4x times 1, and 1 times 4. All right, so where are my like terms? I've got like terms here and here. I need to add those together. So my answer, let me do that in red, is 4x squared plus 8x, because that's me adding that and that, plus 4. So that's my answer. To me, that is the easiest way to do these. Okay, let's do another one. Distribute my 2 in, that is 4x plus 8 times x plus 2. Now, if you can do FOIL and you don't have to do box method, that's great. If not, then just do box method. It's easy, it's fast. 4x plus 8, and this is x plus 2. That's going to be 4x squared, 8x, 8x again, and 16. Like terms. This one and this one, I'm going to add those together when I put the answer down here. 4x squared. Add this one and this one, that's plus 16x, and then plus 16. So this is just multiplication. That's all we're doing, we're multiplying. Okay, so distribute the 5x. That's going to be 5x squared plus 10x. Leave that in parentheses, and then the x minus 3. I'm going to do this with FOIL. Some of you might be able to do this. I don't need that. I'm going to do this using FOIL. So 5x squared, this is my first term, times x. That is 5x cubed. Okay? Then my outside terms, which is 5x times negative 3. That's 5x squared, I'm sorry, minus 5x squared. My inside terms are my plus 10x and plus x. That is plus 10x squared. And then my last terms are the 10x and the negative 3. That is minus 30x. I have two like terms I can combine here. This right here and this right here are like terms. I need to combine those. And again, this might be easier for you or the box method. It doesn't matter to me which way you do it. That's going to be 5x cubed plus 5x squared, because that plus the negative 5 is 5x squared, minus 30x. So I was just checking my key, and I realized what I did was when I multiplied the 5 times the negative 3, I put a 5 right there. That should be a 15. So then negative 15 plus positive 10 would make this a negative 5. So let me erase that and put minus here. And then I think the rest of it is correct. I just want to make sure that that's negative 30x. Yep, okay, so that looks right. Okay, I'm going to work a couple more of these, and I think I'm going to leave the last one for you. And is this our last section? We got one more. Okay. Okay, so this is just a -1 right here. So if I distribute that -1 in there, I get -1x minus 4. And then my x plus 4. Okay, so I honestly think box method is the easiest way to do this. -x minus 4x plus 4. That's going to be -x squared. -4x, -4x again, and that's going to be -16. This and this are like terms. So my answer is -x squared minus 8x minus 16. All right, I'm going to do one more. We'll do this last one. Distribute the -2x in there. That's going to be -2x squared minus 14x. Leave it in parentheses times x minus 6. That is, let's see, -2x squared minus 14x, x minus 6. Just be really careful when you multiply here. -2x squared times x is -2x cubed. -14x times x, -14x squared. This is going to be -6 times -2x squared. That is 12x squared. And -6 times -14x, I think that's going to be positive 84x, I believe. Okay, so where are my like terms? This and this are like terms. So I need to be sure and combine those. So my answer is -2x cubed. And then my -14, my positive 12, that's a minus 2x squared plus 84x. Okay. All right, I want you to try this one. So I want you to try this one by yourself. All right, we have one more section, and this is more factoring. I think these are still all, yep, these are still all coefficient of 1, so the x doesn't have anything in front of it. Okay, so when we factor to solve equations, we just keep that 0 kind of where it is, and we factor this part of the equation. So what I'm looking at is I'm looking for factor pairs of -20 that when I combine them, when I add them together, I get +8. So let's think about factor pairs of -20. I'm thinking 10 and 2. Okay, so -10 times +2 or +10 times -2. So which one works to give me a +8 when I add them together? Well, that would be this one right here. So I'm going to factor the left side. Okay, so I took the +10 right here and the -2, and that's where I got that, and then equals 0. And then what I do is I take each one of these and I set it up equal to 0. So x plus 10 equals 0. X minus 2 equals 0. And then I just solve for x. So if x plus 10 equals 0, x equals -10. If x minus 2 equals 0, x equals 2. So this is my answer. All right, let's try another one. 6. Okay, so I got a 6 and a +5. I've got a +6, so I need something that when I multiply it together, I get 5. Or when I multiply it together, I get 6, and then when I add it, I get 5. Well, 1 plus 6 is not 5, but 2 plus 3 is 5. So when I add these, I get this. Okay, so then my factor, my binomials are x plus 2 and x plus 3, and it still equals 0. So then I set each of those up equal to 0. X equals -2 and x equals -3. What these are is these are parabola. So when you look at them on a graph, the graph, what it's going to do, so it opens up, and it would, actually this one won't look like that. Sorry. Let me try that again. This one does still open up, but this is the y-axis, and this is the x-axis. So it would look something like this, where this is -3 and this is -2. So that's what these mean. They are the x-intercepts on the graph. Okay, I want you to try the last two on your own. So, do that all the time. So let me do this with the mouse pad. Okay, there we go. So I want you to try this one. And I want you to try this one. So I only left you a few to try by yourself. All right, so I'm in the lab lesson until the end of class today. Come back in if you have any questions.